Good morning. Let us begin a new topic, integration. What is integration? Do you have any idea about it? Okay, we have discussed about differentiation and its properties. So recall all the properties of differentiation. And in differentiation, we have discussed only about the differentiation of power and its properties such as chain rule, then the functions such as increasing functions, decreasing functions, maximum value, minimum value of stationary points, etc. So recall all those concepts before starting with integration, because integration is the other process of calculus. So here the topic, the branch calculus, is divided into two parts. One is differentiation, the other is integration. Okay. So differentiation is the first basic tool of calculus, and integration is the second basic tool of calculus. And we can say integration as the reverse process of differentiation. So here it got work simple. Integration is the reverse process of differentiation. Okay, so now you might have got the idea about integration, how integration is connected with differentiation. It is the reverse process of differentiation. Okay, it has many applications like planning spacecraft flight paths or modeling real world behavior for computer games and so on. Okay, so let's start the topic integration. In differentiation, you have learned the important concept as if y is equal to x raised to n, then dy by dx is equal to n into x raised to n minus 1. Yes, our total differentiation was based on this in AS level. When we go to EA level, there we learn differentiation in a broad way, like differentiation of trigonometric functions, logarithmic functions, etc. Okay, now in this topic, in integration, the term dy by dx will be given. We have to find y. In differentiation, y was given, we have to find out dy by dx. In integration, dy by dx will be provided. You have to calculate y, or equation of line. So let us find the derivative of these 5 functions. Tell me, what is the derivative of y is equal to x raised to 5 plus 8? What is the derivative of x raised to 5 plus 8? It's nothing but 5x to the power 4. So what is the derivative of this one? Next function, that also 5x raised to 4. What's the derivative of this? 5x raised to 4. Sorry, this is 5. Let's write it as 5. So when you consider all these 5 functions, they all give the same differentiated answer. What is that? 5x raised to 4. 5x raised to 4 is the derivative of all these 5 functions. Is it the derivative of only these 5 functions? No, it is the derivative of infinitely many functions. Okay, so if the question is dy by dx is equal to 5x raised to 4, and you want to find out y, they have given dy by dx. Now this is a new process. They have given dy by dx is 5x raised to 4 and your required answer is y. What is y? Which y you will take here? Does it this or this? Because this all gives us dy by dx. Okay. So when you consider these all questions, they differ only by one thing. What is that? C, the constant. The constant is different. Yes, there is a constant. So here y is formed by, we can say this y is formed by x to the power 5 plus c, a constant. Okay, so that is the difference you could find in all these functions or infinitely many functions with x raised to 5. There is a constant. In differentiation, that constant doesn't matter, but in integration, that constant matters because that is also a part of y. Okay, so clearly differentiation is the change of y to dy by dx, and integration can be called as anti-differentiation. So what is integration? It is anti-differentiation. Now let's go for the rule of integration. If dy by dx is equal to x raised to n, then y is equal to, because when we integrate dy by dx we get y, because remember the concept, it is the reverse process of differentiation. Y is differentiated to get dy by dx. That means if we integrate dy by dx we get y. Okay, so y can be found by using the formula 1 by n plus 1 into x raised to n plus 1. 1 by n plus 1 into x raised to n plus 1 plus c. Why we got a c here? For that we discussed the previous 5 examples. There were a c remaining, a constant were remaining there. So y is equal to 1 by n plus 1 into x raised to n plus 1 plus c. Like dy by dx is equal to 5x raised to 4. This was the dy by dx we discussed in the last question. We need to find the value of y. So y is 5 into, when you integrate x raised to 4, when you integrate x raised to n, it is 1 by n plus 1 into x raised to n plus 1. So x raised to 4 can be written as 1 by 4 plus 1 into x raised to 4 plus 1 plus c. So we get it as 4 plus 1 is 5. 5 into 1 by 5. 5 and 5 get cancelled. So we get the answer for y as x raised to 5 plus c. I hope you recall the previous example. There also we got the same answer, isn't it? Okay. And another thing, when we use this integration, the value of en should not be 1. It's not 1, minus 1. Should not be minus 1. For example, you got dy by dx as 1 by x. We want to find the value of y. So 1 by x is x raised to minus 1. So to find it, we need to integrate it. So as per the integration, we get it as 1 by minus 1 plus 1 into x raised to minus 1 plus 1 plus c. That's equal to 1 by minus 1 plus 1 is 0. What is 1 by 0? It is not defined. So our answer becomes not defined. Yes. That means you cannot integrate 1 over x using our normal integration. So you learn how to integrate this function in A level using logarithm. Okay. And the special symbol we use to denote integration is this one. Suppose you want to integrate x cubed. You want to integrate x cubed. Just write x cubed in integration sign. We have to read it as integral. Integral x cubed followed with dx. So when you write a term with integral sign, there should be a dx. It's very simple why you meant by dx. Suppose our derivative is dy by dx. When you want to integrate dy by dx, we write it as integral dy by dx. Okay, so this integration is on y. This integration is on y, not on dx. So when you integrate dy, dx is an extra factor here. So we multiply it with dx. So that we get integral of dy as y plus c. Okay, so whenever you write integration, we write integral x raised to n dx is equal to 1 by n plus 1 into x raised to n plus 1 plus c, where n is not equal to minus 1. So this symbol is very important, and when you are doing with sign, there should be dx. Okay. There are mainly two types of integration. They are indefinite integration and definite integration. Indefinite integration and definite integration. So let's discuss about indefinite integration. First, integral x raised to 5 dx. For example, integral x raised to 5 dx is called the indefinite integral of x raised to 5 with respect to x. So this integration is to be done with respect to x, because as our term is x raised to 5, it should be integrated with respect to x. To mention that this dx is given here. Okay, if you get a question, integral y raised to 5 dx, this integration is with respect to x and your term is y raised to 5. You cannot do integration here. To do this integration, it must be dy. Okay. So integral x raised to 5 dx is called as an indefinite integral of x raised to 5 with respect to x because it has infinite solutions. We can find infinite solutions for this question. That's why it is known as indefinite integration. For example, dy by dx is equal to x cubed. We need to integrate it. So when you integrate it, we get y is equal to integral x cubed dx. That's equal to, when you integrate x cubed, we get 1 by 3 plus 1 into x raised to 3 plus 1 plus c, which is equal to x raised to 4 by 4 plus c. So this question has, when you integrate dy by dx, that is integrate x cube dx, we got y as x raised to 4 by 4 plus c. It has infinite number of solutions because we do not know the value of c. For each and every point, for each and every value of x and y, we get different solution for c. Okay, like for example, if x is 2 and y is 1, we get 1 is equal to 2 raised to 4, 16 by 4 plus c. That is c is equal to minus 3. We get c as minus 3. So that this equation become y is equal to x raised to 4 by 4 minus 3. This is one solution. Instead of that, if x is 3 and y is 5, we get another solution. So this question has infinitely many solutions. That's why it is known as indefinite integration. And same like differentiation, here also we have a few laws to be followed. Just integral k fx dx, that is multiplication with a constant, is same as k into integral fx dx. Like when you integrate 3x raised to 6 dx, we can write it as 3 integral x raised to 6 dx, that is 3 times 1 by 6 plus 1 into x raised to 6 plus 1 plus c. That is 3 by 7 x raised to 7 plus c as answer. And another law you need to remember is integral of f of x plus g of x dx, or minus, which is integral f of x dx plus or minus integral g of x dx. Like for example, you have integral x cubed plus x squared dx, can be written as integral x cubed dx plus integral x squared dx. Now we have to integrate it. We get x raised to 4 by 4 plus x cubed by 3 and write overall 1c plus c. No need of bracket. Don't write c here and here. Just we can write only 1c here. Okay. In the next class, we discuss about how to find the constant of integration. Okay, thank you.